Welcome to MSc Educational Week 2011. First and foremost, I would like to welcome our guest speaker, Mr. Erwin Watterson. Thank you for attending our session this afternoon. Also, a warm welcome to our dear MSc students who have taken their time off this afternoon to attend this event. Educational Week is an opportunity for the students to foresee what is in store for them upon graduation. The industrial visits, the talks, provide our students with well-informed insights of what's coming ahead of us. Today is the second day of the series, and I think my course mates will agree with me when I say that much has been learned, and there's much more to learn. This year, our theme for the Educational Week is Cleaner Energy, Brighter Future. Today, we have representatives from Vestas, Global Foundries, and Renewable Energy Corporation. We will be having a question and answer session after each talk, so please keep in mind any questions that you might want to bring up. Without further ado, we shall begin our EduWeek Industrial Talk series. To start off, I would like to call Mr. Erwin Watterson from Vestas. Vestas is leading businesses and non-profit organizations to develop global consumer label for companies using wind energy. Mr. Watterson, please.
Good afternoon, everybody. My name is Erwin Watterson. I'm here today to tell you more about Vestas, about what we do, and I think most important, I want to show you how you as a materials engineer actually can contribute in a company like Vestas. Maybe you can go to the next slide. This is roughly the outlay of my presentation. I'll start with an introduction about myself. I'll talk about Vestas, about the organization, what kind of products do we have, and actually why are we working in the wind sector. And I want to end this presentation with a more focus on material research, because I think that's more important for you guys. You know, how can you apply the knowledge and the experience that you get from your course in MSc, how can you apply that to the industry? If you go to the next slide, maybe I'll start off to tell you more about myself. I'm a principal engineer in the rotor systems department here in Singapore. Was established in 2007. I joined in October 2007, so I'm quite a dinosaur in this company. My expertise is in the field of composite materials, nanotechnology, joining technology, as well as coatings. And you can see I did my PhD actually here in MSc in material science, and that's why I'm happy to be here, because I can quite relate to you guys on how you feel after your graduation, what you want to do, where you want to go. So I think that's why it's good for me to be here, so I can share my experience with you, and I hope I can inspire you for your next step in your career. What I did in my PhD was I worked on foam-based composites. It was on the supervision of Freddie Boyd, who was my supervisor. I spent a total of 6 years here. This is quite long, because I thought it was quite boring to work 3 years full-time on my PhD project, so I took up a lot of other projects with Professor Majal and Professor Subu. So we did most of the bio projects, as well as the piezoelectric. So that was quite fun, because it gave me a lot of exposure to other technologies, other industries like the medical industry, like the electronic industry. So I think that was a very good basis for me to move out of MSc and work in the industry. Because in the end, the industry is quite different from your research area. It's much more fast-paced, and there's a lot of decision-making to be done. Before I came to Singapore, I studied in Delft, in Holland, where I did my Master of Science in Aerospace Engineering, also focusing on materials. So if you can see on the left, I worked on a project with the Dutch Air Force, where I worked on the F-16, and they had some fuel vent hole problem. So we investigated the fatigue record. After that, I joined for a while a program where I worked on the Airbus A380, where we did some of the materials here on top, which is called a material called glare, which is a fiber metal laminate. Again, we investigated the fatigue record. And some of the other projects I did here at MSc, I don't know whether you heard about it. It's a product called Retract. It's what we developed with Freddie Boyd and a company in the US called Incitra. So it's a tissue retractor system which can actually stick on the body. I mean, it's a very simple concept, but nobody ever thought about it. So we filed a patent, and we we tied up with a company in California, and currently they're selling this product to the various surgeons. So I think it's about 60,000 units a year. Should be growing to about over 200,000 this year. So that's quite an interesting experience. And with Professor Majan, I worked a lot with Santoxin Hospital, where we worked to make medical devices for cataract, for implants, etc. And that's me. Actually, it was last week. So my voice is not fantastic because actually last week I was in Sweden, where it was -20. So I go back to 30 degrees this year, today. So it's quite a thermal shock for my body. So my voice is not fantastic. But investors, you get to travel quite a bit. It's quite interesting. We get to visit different sites around the world. So I had the opportunity to go to Sweden, where we have a project on one of our turbines, and I can tell you it was very cold. Maybe the next slide? Okay, let me tell you more about Vestas. Next slide. So here you can see the history of Vestas in a nutshell. I won't go into too much details. It started way back in 1898, where Mr. Hansen moved to Lem in Denmark, and he started a blacksmith shop, and his business grew tremendously, so it was very much metal-based. And in 1945, his son took over the business and actually established a company that was called Vestas Stahltechnik AS, and that eventually became abbreviated to Vestas. Initially, in the beginning years, Vestas focused on the development of home appliances, agricultural products, and it was not until 1979 when Vestas went into the wind energy, and that was mainly driven by the fuel crisis in the 70s, especially after the second one. Vestas thought it's a good idea to go into the renewable energy, and they chose to go into the wind. So in 1979 we made our first wind turbine, which was a 3-bladed one. So we designed something like this, but then much smaller. We call it a 3-bladed, of course, because there are 3 blades. Now, a lot of people ask why 3, why not 4, why not 5, and that's mainly because based on economics. You can get a slightly higher performance, but you pay a much higher price if you put 4 or 5 blades. You have to make more blades. It's more cost. You have to maintain more blades. So we did a calculation and we said, okay, 3 actually is the best. So after 1979, Vestas grew tremendously. There was a large interest from the US market, from the Spain, and we made a lot of new products. And in 1987, actually Vestas was established on its own. So it split out of the Vestas group. A lot of departments were actually closed down because of some crisis, but the wind remained and became the main focus for Vestas. And since then, it's still growing. I don't know whether you have read up about Vestas and the market for wind energy, but it's still growing almost exponential. It has cooled down a bit in the recent years because of the global crisis, but we're still growing rapidly. Another main event in the history of Vestas was the merger with Energy Micon. Energy Micon was a company from the United Kingdom, who was also one of the biggest players together with Vestas. So once the two companies merged, we became the market leader in the wind energy, which we still are. Last year we had a market share of 12.6%, and I haven't seen the latest numbers, but I believe it should be higher because we had some mega orders last year in terms of about 1,500 megawatts on turbines, which is a lot. And the total orders, I think, was in the order of 8 gigawatts of turbines that we have. Okay, maybe we can go to the next slide. So here are some of the numbers. Vestas has installed in total about 41,000 wind turbines, which is far the biggest in the market. Like our competitor, second competitor is General Electric from the US. They have installed only 20,000 wind turbines. So we have much more experience in building wind turbines, installing them. We've installed them in about 65 countries all over the world. So I'm sure if you travel for your holiday, you might see a wind turbine somewhere. Of course, not in Singapore, because here the wind is not too strong enough to have a wind turbine. But if you travel to China, you travel to Japan or to Europe, there's a high chance you might see our turbines. We can go to the next one. Okay. Vestas is is a company that does the whole value chain. And what that means is we do the R&D, we do the design, we do the production of the turbine, as well as we do the installation and the servicing. So we do the whole value chain. And because of that, and because we are in so much countries, you can imagine that also our production facilities are all over the world. For example, nacelles, which is this box here on top, that's what we call the nacelle. It's fabricated in 15 countries. Our blades, we make them in 7 different countries. So we make them in Denmark, we make them in Spain, we make them in Italy, China, the US, and Germany also. And the towers also, we make them in 2 locations. So the reason why we make them at different locations is because you want to be close to your customers. Once you start looking into the cost, you find out that actually logistics is a very high component of the cost of wind turbines. So the shorter the distance to your customer, the better price you can offer. So that's why we're spread out all over the world. Can you go to the next slide? I don't think it's also a surprise, since we have so much countries in the world. There's a lot of different nationalities in Vestas. We have about 22,000 people at the moment. So we're not that big, we're also not that small. But we have about 87 nationalities. And here you can see a lot of my colleagues. Some are from Singapore, some are from Europe. For example, the office here in Singapore, we have about 16 nationalities. So we have people, of course, from Singapore, Malaysia, Vietnam. We have people from China, India, of course, from Holland. We have people from Australia, United Kingdom. So you get to work with a lot of different cultures, which is interesting and can be quite challenging also at times. But I'm sure, since you guys are from Singapore, you're very used to working with different cultures. So for you guys, it won't be an issue. But for Europeans, it can be much more of a challenge to understand why Singaporeans behave in this way, and Chinese behave in that way, and Indians have these habits. So it can be quite a challenge and it can be quite frustrating sometimes. Next slide. Okay, for the economics unrust, here's just some of the numbers. The Q3, I have an update with the Q4, which was recently announced. But the revenue in Q3 was about 1.7 billion euros. Overall, in 2010 we hit about 6 billion euros. And just to share with you, the vision of Vestas is to grow this 6 billion euro revenue to about 15 billion euro by 2015. So we're still quite ambitious to grow this company. And the EBIT last year was about 5 to 6%, and that should also grow to about 15% in 2015. So we're still doing quite well, despite the global crisis last year. It hit Vestas also. The order intake was quite low, but we saw last year is picking up again, so we hope that this year it will continue again. Can you go to the next slide? Okay, here are the vision and the mission. Every company has a vision and mission, and for us it's wind, oil and gas. And what we mean by that is that we actually believe that wind energy could be on par with oil and gas industry. People always talk about oil and gas and leave out the wind, but we think from competitive point of view as well as economic point of view, we can actually fight with oil and gas. The oil price keeps going up, but wind is free. So in terms of money, we can fight. It's just that certain places you might not have enough wind, so you have to find alternative solutions. And our mission is failure is not an option, and that's because we want to deliver products that are reliable to our customers. You don't want to design a product that after 1 year, 2 years fails. It might be cheap, but if it fails, there's a high cost factor. So imagine if my blades fail. This blade could be like 44 meters. The height is like 100 meters. So you need to get in a crane to shut down the turbine. Once you shut down